I want to briefly look at how to graph y equals 3 tangent of 2 times the quantity x minus 45 degrees plus 1. If this was in radians, that would be minus pi over 4, but I'm going to do it in degrees here. Anyway, the same ideas as normal work. For example, we've got a plus 1 here. That means that the midline is going to be at 1. So you can see I've drawn the midline in there. The key things I really want to see are the intercepts, the midline, and the asymptotes. Okay, I'm not so worried about individual points being plotted other than those kind of key things. So a couple things here. The normal tangent function, if we go back and look at the normal tangent function, it's got intercepts every 180 degrees. Remember, that's the period. So, the period of this function would normally be 180 degrees or pi radians. However, we've got this multiplier of 2 here, so it's moving 2 times as quickly. Period's going to be 90 degrees, okay? Everything repeats every 90 degrees, okay? I usually look at the intercepts, okay? So this hits the axis, normal tangent function, 0, 180 degrees, 360, and so on. And you can see I've got that here. So we're going to make this happen twice as quickly, or move twice as quickly. Each of these would be divided by 2, okay? So it's going to cross the axis at 0, 90, and 180. So I'm going to put a point here at 0 along y equals 1, and 90, I'm going to put a point there, and then I'll put a 180 in here, and I'll put a point there, okay? So that's where this function is going to come through, okay? The asymptotes are going to come exactly between that. So, you know, you could think about where the asymptotes normally are, negative 90, 90, 270, and so on, and you could divide each of those by 2. So we're going to have asymptotes at negative 45, and half of this would be at 45, and half of this would be 135. Or you could just put it halfway in between the intersection points. It really doesn't matter. So like, you know, the function basically is, the asymptote will be halfway between these 2 points here. So the asymptote will be going through, oh, we have a problem here. There's a horizontal shift as well. So I have a little bit more going on here than I thought I did. Okay, well, let's take care of that first then. All right. So this is not where these are going to be because there's a 45-degree shift to the right, okay? So instead of having points at 0, this is going to get shifted 45 degrees to the right. We're going to have an intersection point at 45, okay? This is going to get shifted 45 degrees to the right. We're going to have an intersection point at 135. Okay, and you might want to put 45 in here, and you might want to put 135 in there. And then this will get shifted over 45 degrees as well, and that'll be at 225. Okay, so that's where your intersection points are going to take place. And so the asymptotes will be exactly in between these, which is interesting, actually. So the asymptotes would have been at negative 90 divided by 2, negative 45, 90 divided by 2, which is 45, and 270 divided by 2, which is 135. However, we're going to add 45 to each of those as well. And so that's going to end up taking us to, if we add 45 to each of these, it's going to end up taking us to 90, well, it's going to take us to 0. It's going to put one at 90, and it's going to put one at, what is that, 180, I think. Anyway, so you can decide. I usually just focus on the intersection points, and I know the asymptotes are going to be halfway in between. So basically, we're going to have an asymptote here, and we're going to have an asymptote here, and we're going to have an asymptote, actually negative 45, there'd be another point. So we'd have an asymptote here at 0 in this particular case. And then really you can just draw your function in. Now you do have this multiplier of 3 out here. This technically should be a little bit steeper than these original graphs. But if you notice, I didn't really put a y scale on these either. So I'm not really going to do too much with that. But the big thing is we would have a pretty steep function coming through this point, going to that asymptote, maybe doing that sort of thing. Okay, and then we're going to have a pretty steep function coming through that point, going like that. Pretty steep function coming through that point, going like that, and then approaching that asymptote, doing that sort of thing. So, you know, your graph might look something kind of like that. But again, I need to see that midline, which should be very easy to get from this point here. I want to see the intersection points, which are going to be affected by two things. You're taking those original intersection points from the standard tangent graph, you're dividing by whatever this value is, and then you're shifting either right or left based on what this position is. And that's how you get your final graph. So a little bit more complicated, but that's the basic idea. And it really works the same way that our other trig functions do if you know the features of the tangent function.